Hi all, this video is for our secure software development module assignment. We'll briefly walk through the key vulnerabilities we identified and the fixes we implemented across the front end and the back end. So first we move on to the OpenID connection for the Google authentication. So from the front end we call into the start endpoint in here with the redirect URL, and then it calls to the Google authentication service, and from the our Google account we can log in. What happened is after that verified this it's called to the callback URL. In that from the OpenID client it exchanges the claims like email and other details that need. Then it called to the auth login endpoint in the user service microservice and upsert the user. Then after that it callbacks to the callback page in the front end, save token and user to the local storage as our usual login flow. Now I move on to the vulnerability that I found, which is from the SAP CSP defined directive with no fallback. That CSP vulnerability was fixed by adding helmet hit library. With that adding strict directives, defaults like self limiting script styles, and also referrer policy to the no referrer, and strict course allow list. We fixed that CSP vulnerability. Thank you.
Hello, I'm Bhavan Randunu. I have identified mainly two vulnerabilities in this code base. First one is logging and vulnerability and missing try-catch blocks. In there, I have observed the logs are data breaching, sensitive data breaching from the logs. For that, I have implemented the wisdom logger. In wisdom logger, we have replaced all the loggers with the avoiding personal information. And the second one is error message leakage in response. In the error response, the messages are leakage, the unwanted infrastructure informations are leaked for the unauthorized person. For that, I have write the error message without the unwanted information. And the third one is missing try-catch blocks. In here, I have seen some asynchronous method functions do not have try-catch blocks that may cause for the DOS attacks. So I have implement all the try-catch blocks for all the asynchronous functions. And the second vulnerability that I have been seen in this code base is potential issues and vulnerabilities in the Docker file. In the Docker file, I have observed the previous Docker file has the old image and the broad image. That's not this slim image. In broad image there has been broad area, and there is more possibility to attackers to attack. And also in the older one, the older Docker image, the container is running in the root permission, but that is not, that also a vulnerability. But in here I have make a user and run it in the several specific user from the specific user that can only do small limited permissions. And also in here I have put the all the environment variables in the some production environment variable, and that's are not exposed in here. And also before running the container, I have been checked the infrastructure health, because the if the infrastructure is not good for running this container, it may cause for those attacks. Those are the vulnerabilities I have been seen in this code base. Thank you.
Hi, I'm Urudhi Atawaka. Hi, I'm Urudhi Atawaka. In this application, I have identified two vulnerabilities. The first one is unauthorized WebSocket broadcast and missing drivers verification. As you can see, in this application, previously they only used socket IO, they were only shared broadcast to all consumers. It can be a risk for that application. For that issue, I have implemented safest way to uh, to avoid that uh, security reason. And for that, I used socket authentication with JWT. As you can see, we used users web token to identify and authorize. And after that, we verified the driver. And when we get the JWT token, we can get driver's ID. And after that, we are checking from our database is there is any driver from that ID. And after that, we used delivery specific room for broadcasting fix. That means we are not broadcasting for all consumers. We are creating a room for drivers. And we are uh, we are passing that through our room. And my second vulnerability is unvalidated and unsanitized Kafka message. Previously, they didn't use sanitization. uh, in my updated code, I used validation for incoming Kafka messages. I used joy schemas for that. And I created a joy schema, uh, like what should be the structure of that Kafka message. From that, we can uh, we can secure our system without crashing the invalidate Kafka messages. And in this code, we are sanitizing our Kafka message is a string, like if it is not JavaScript or some scripting code. And also they didn't use try catch blocks for Kafka messages. uh, and I added that also for safe for the safety of without crashing our application.
Hi, in this video I will explain two vulnerabilities I have worked on my application. The first one is IDOR attack, means insecure direct object references. First I fixed IDR in issue. IDR issue in order management service. Originally a user could change the customer ID or order ID in the API request and see other users' orders. This means attackers could see private information like delivery information and payment history. To fix this, I updated the order control to verify ownership by using user ID and the role ID that comes from the JWT token. The API gateway now passes this information in custom headers. So only the order owner or admin can view an order. If someone tries to access another customer's order, the system returns an forbidden 403 forbidden error. This prevents unauthorized access. The second vulnerability I have worked on is XSS attack, which is cross-site scripting attack uh, caused by unsensitized user inputs in restaurant creation and reviews. Attackers could inject malicious scripts into fields like restaurant name, location, so on. Uh, in here, if I going to create a restaurant using this name script as the restaurant name, it will show error message in restaurant name contains invalid characters, so it's too long. Mm, it's creating the restaurant. Mm. To fix this, I added input validation and sanitization on both backend and frontend. On the backend, I use the validator and isomorphic DOM purify packages to escape and strip dangerous HTML before saving to the database. Uh, on the front end, I added validation functions to block HTML tags and also use DOM Purify to sanitize any user generated content before rendering. Together, these changes protect the app from stored and reflected cross-site scripting attacks. Thank you.